Hello, so in this video we're going to look at an example where the right hand side of our non-homogeneous second order differential equation, where the right hand side is following a polynomial. So in other words, we've got the general form of a polynomial. Okay, and so if you remember in the last videos, we found the complementary solution of this differential equation. So in other words, the non-homogeneous, the homogeneous solution to the differential equation. This is non-homogeneous because the right hand side is not 0. Okay, well we first of all find the complementary solution, which is solving the homogeneous equation. So we just set the right hand side equal to 0, so we effectively just null that and set it equal to 0. Okay, and we came up with that. And remember, we seek a solution to this thing. A general solution to this thing will be the complementary solution plus some particular solution. And the idea is in this video that we're going to find that particular solution, just like we're doing in the last couple of videos. Okay, so basically the first thing to do is to try and guess a solution, and we guess a solution based on the right hand side. Well, this solution on the right hand side is this right hand side is a polynomial. So it's a polynomial. Just remember, is just like some constant. So some constant, let's call it a0 plus another constant times x plus another constant times x squared, and so on and so on and so on. So this would be like a quadratic, yeah. Well, at the moment this is a quadratic because the highest power on the right hand side, you can always tell. It's just GCSE or A level stuff, or whatever. You can always tell what a polynomial is called. It's quadratic, cubic, whatever, just by looking at the highest power, which our independent variable, in this case it's t, is raised to. So in this case it's raised to 2, so therefore we know it's a quadratic. So what I'm going to do is I'm going to guess that my solution is going to be something that looks like a quadratic. So I'm going to guess the general solution, the general form of a quadratic. So at squared plus bt plus some constant. Yeah? So basically, I just look at the right-hand side. Polynomials are dead straightforward, just like they are for exponential. But polynomials are dead straightforward, because you just look at the right-hand side. Effectively, all you do when you try and find a particular solution is you try and generalise the right-hand side as much as possible, or as much as you see fit, as much as necessary, while still keeping some of the DNA which the right-hand side has in. So, for example, when it was sine, it'll be sine of some angle, for example, then you keep the 2t, okay, in your general form, but you just stick in coefficients in front of them. And likewise, when it was e to like the 3t, you just stick in some constant in front of the e to the 3t, but you keep the 3t the same. Yeah. So in other words, you keep some of the DNA. So this is just basically, you're trying to generalise this right-hand side. So in other words, where there should be a constant, then you just put a constant there. Okay. So here's what I guess it's going to look like. It's going to look something like this. So the first thing we need is the first derivative, and we also need the second derivative as well from that. Okay, to put it in there. So let's have a look. So let's differentiate this. We end up with at, or 2at, sorry. Differentiate that. 2at plus b, and then the constant c is just a number, so when we differentiate it's just going to go to 0. Okay, and likewise when we differentiate that to find the second derivative, it's going to be 2a plus 0, because the b is just a number, so therefore when we differentiate a number it's going to go to 0 as well. So now what we're going to do is we're going to plug this back into there, so we end up with, so let's try and replace this. So in other words, we're going to replace our y with that thing there. There we go. Does it fit? Just about. There we go. And then y dash we're going to replace with that thing there. So I'll just be careful here because it's all times that. Okay. And that's likewise, that is all times that as well, because it's minus 4 times all that. Then we just got y dash on here, so we just end up with 2a in here. Okay. Let's just expand it out and just make it look a little bit neater. So we end up with 2a. Okay, minus 6at minus 3b, so I've just expanded that thing out. Okay, and then expand that thing out as well, so we end up with minus 4at squared minus 4bt minus 4c, and that's all equal to 4t squared minus 1. Okay, do a little bit of tidying up now, so just collect together like all the a's and collect together. Go on. Basically, we want to write this left-hand side something like the right-hand side. Okay, so then we can compare coefficients. So in other words, we want to collect together all the because we've got t squared, t's, and we just got constants then. So we want to collect together all the terms involving t squared and all the terms involving t. So just write it like an ordinary quadratic. So I'm going to collect that one at the front. So minus 4at squared, okay, and then I'm going to collect together all the terms involving t. So there's one there, so we get minus 6at, okay, minus 6at. There's a t there as well, so minus 4at, okay, and then we just write together all the constants. We end up with plus 2a minus 3b minus 4c. Okay, and that's all got to be equal to my right-hand side. So minus 4 is equal to 4t squared minus 1. Okay, and then the first thing which I'm going to do is just compare the coefficients. Well, actually, before I do that, I'm going to do a little bit more to this. So I'm going to say that there, that minus 4a is the coefficient of t squared, just to make it look a little bit kind of more like it. I'm going to stick a plus in there, and I'm going to say, right, that there is all the, I've just taken a t out of those two things. Therefore, that is the coefficient of t. Okay, and then this is just my constant term on the end. Now here, you notice I haven't really got a t in there, except I have, it's kind of hiding with a coefficient of 0. That's why it disappears, and I just got a minus 1 on the end. Okay, so hopefully that just fits into the screen so you can see what I'm doing here. So let's have a look then. So that must be equal to the, the t squared. Let's compare the t squared terms together. So minus 4a t squared has got to be equal to 4t squared. Okay, so that's that. And then we end up with, what else do we end up with? We end up with minus 6a minus 4a, lots of t, has got to be equal to 0t. 0t. And then let's just look at the constant term. So 2a minus 3b minus 4c, that's got to be equal to minus 1. That's got to be equal to minus 1. So let's get rid of all the stuff we don't need. Well, there's a t squared there and a t squared there. Let's get rid of that. There's a t there and a t there. Okay, so now it's just a case of trying to simplify this down a little bit more. Oops, I think I made a mistake when I've copied it down. That should be a minus 4b in there. That should be a minus 4b there, which means that that should then be a minus 4b. So sorry about that. Hopefully you spotted that before I had. But yeah, I think the rest of it is okay. Let me just double check. Yep, that's all okay. That is all okay. Okay, so now basically what I want to try and do is I want to find out what A equals, and I want to find out what B equals, and then I want to find out what C equals. Well, look, I can easily find out. Okay, this is just a set of simultaneous equations, right? So I can easily find out what A is just from this first one. So I can easily see that minus 4A equals 4, which implies that A must be equal to 4 over minus 4, which is just going to become minus 1. It's going to become minus 1. So I now know that A is equal to minus 1. So I can sub that back into here. I can sub that into here. So if I replace this by minus 1, this then becomes plus 6. Okay, so I end up with plus 6. So 6, basically. Minus 4b equals 0. So let's take this 4b on the other side. So we end up with 4b equals 6. So therefore b must equal 6 over 4, which is of course just 3 over 2. So b is equal to 3 over 2. Okay, so now I can use those two things in this last one. I can now use those two things in this last one. So I end up with 2 times minus 1 is going to become minus 2. And then minus 3 times 3 over 2 times 3 over 2 times 3 over 2, that's going to become minus 9. Minus 9 over 2. Minus 9 over 2, minus 4c equals minus 1. So let's take this minus 2 on the other side. So this is going to become minus 1 plus 2. That's just going to become 1. Yep. And then I'm going to take this minus 9 over 2 on the other side. So that's going to become plus 9 over 2. So what is 1 plus 9 over 2? Well, if I convert this into 2 over 2, that's going to become 11 over 2. It's going to become 11 over 2, and then I say that minus 4c is equal to 11 over 2, so therefore c must be equal to minus 11 over 2 times 4, effectively, so minus 11 over 8. Okay, so therefore I've got all my values for A, B, and C. Well, remember what my original thing, which my original solution which I tried was. That was the original solution which I tried. So therefore I can just replace A with that one, A with minus 1. Oops, A with minus 1. B with 3 over 2, and C with minus 11 over 8. C with minus 11 over 8. And now if I plug this, back into here, up here, okay, so now if I plug this up into here, then I will get my right-hand side out. So therefore I've found a solution that satisfies this particular equation. Okay, so it's a particular solution. So this is my yp, so therefore my general solution is going to be y equals yc, which is just the c1 e to the 4t plus c2 e to the minus t, plus my particular solution, So my particular solution is just going to be that thing there. It's going to be this thing here. So there we go. That is my general solution that will satisfy that equation. Okay, so basically the whole idea behind polynomials, what do I have to try when I've got a polynomial? I try the solution y equals, my general form of my polynomial on my right-hand side. So if this was a cubic, for example, I'd try at cubed plus bt squared plus ct plus d, etc. If it was a quartic, I just raise, I just write out my general form each time. So basically, I just try the general form of my right-hand side all the time. Okay, and this is actually, in this case, this is my general solution of my polynomial of this differential equation. Okay.